It's my pleasure to start this second session. It is on enhancement of public health through technology. It's my pleasure to ask Ramesh Rao to come to the podium to talk about cognitive health care from Android infrastructure to optimal information acquisition. Ramesh?
This talk was, this abstract in this talk was submitted by Tara Javedi, a colleague of mine in electrical and computer engineering. Unfortunately, she had to get on a plane and fly off to give another talk. So this is sort of like the nerdy ECE part of us. What we really do, both Tara and myself, at the end of the day, when we have won the proposal and got the money and so on, is scheduling, optimization, and stochastic performance analysis. But why did we get involved with something that has this broader sweep, cognitive healthcare, from infrastructure to information acquisition, is what I'm going to spend a few minutes talking about. And at the end, I'll have a few things to say about what we might do to enable more work along these lines. As electrical engineers, it's a little scary to attempt to do anything about healthcare. But we remind ourselves that Thomas Edison was thinking about healthcare long back in 1903, so we can perhaps okay. So let me step you through a discussion that takes place within the networking community, which is our home discipline. We spend a lot of time talking about dumb networks and intelligent networks. And actually, there's a lot of great work that goes on to make sure that networks stay dumb. It's sort of like a strongly held belief that the intelligence should be at the end nodes, not inside the network. And what it sometimes means, what it has meant until recently, is don't examine the data that you're moving around, just deliver it. Right? That's kind of the paradigm. And deep down, there's a belief that centralized networks are unreliable. And in fact, that centralized authority is untrustworthy. And you'll realize that the internet, as we've known it, actually does not have a switch. It's not owned by anybody and can't be sponsored by anybody, right? So that's how the store and forward networks emerge. It's deep in how people think about these problems. But I'm trying to convey that that is how the internet once was. And we are all familiar with content filtering at different levels, from your own PC all the way to much higher levels. So things have certainly evolved. There's this other approach to networking, which is often thought of as intelligent networks. And what is implied is that the end nodes are dumb. And here, basically, you're following the context, recognizing the distinctions in the data that is contained in the packages that you're moving around. And you seek to prioritize the delivery of this information. And the ones who promote this are usually much better organized entities. And they will tell you that managed networks are safer. And cellular networks in the old days were a good example of this. Your cell phone was really dumb, it hardly did anything, and all the intelligence was in the network. But today, with smartphones and apps, that has evolved. There are applications that are beginning to make things a lot more smart, right? Outwitting the cellular providers. So as we look to building platforms that might do justice to what we want to do in the context of healthcare, the idea that springs to mind is to go beyond the end nodes and the heart of the network, but think of the people that it will touch, right? How do we create an environment in which we could get more information out of the people that you're trying to help? Some of you have seen this. I'm sure some of you have talked about this, but part of the promise here is that we have a massive installed database already. 2 billion smartphones. I don't mean phones, but smartphones, all of which have all sorts of sensors like accelerometers, GPS, already networked, already talking to each other. And in addition to what they have the ability to connect with other sensors through other kinds of radios. So there is this enormous data stream that's coming our way. It's multimodal, but often it is noisy, right? So this combination of lots of data that potentially has a lot of noise in it is what makes it possible for us to do something as electrical engineers. So there are new scarcities. If nothing was scarce, there would be no problem to solve. We'd all be out of work. So spectrum, as has been pointed out by some companies in this business, is the new oil. You don't have enough spectrum for the demand that exists. Storage and data centers, even though the Googles of the world and Amazon have done enormous amount of work in this space, you can't keep scaling, right? You can't just keep storing all the data that you can generate. You might have to start looking at the data more carefully. And as we all know, battery life doesn't ever keep up with many of these fancy new devices. So these scarcities are what require new innovative sort of algorithmic approaches, scheduling, optimization, and so on and so forth, to squeeze more out of what we have. So what it really comes down to is trying to figure out what in this information stream is salient, what needs to be delivered in a timely manner. And once we figure that out, we can build a system that will do that. Clearly, we need to partner with medicine to understand, from a biological perspective, physiological perspective, what is worth looking at. There are, of course, approaches where you assume you know nothing and just let the data tell you the story. Machine learning has cut everybody's imagination. But we partly want to kind of go beyond this and deal with real people also. So we built a system. I'm not going to tell you very much about the system. These systems are easy to build because these platforms and tools have become commonplace. But one of the things I want to draw your attention to, I doubt you can see this very well, is this ability to annotate your data yourself. Instead of just letting the doctor interpret your data, you just might know something that you want to record. It's another data stream, what's running through your mind, okay? So we wanted to make sure that we would do that. And in our experimental use of this system, and if you're interested, I can go on forever, what it does is it opens up a conversation with the people. Here's one example, just to amuse you. This is a young lady, a graduate of the Jacobs School of Engineering, who was persuaded to try out our system. This basically shows a trace of her heart rate, RR intervals, and this is what we got from her. And when we sat down to talk to her, we said, I'm sorry, the sensor was, defective. There's a lot of noise. You can see all these weird squiggly lines. She looked at the data and she said, she was pregnant. She looked at the data and she said, that's my baby kicking. Okay? If you blow it up, which is what we have done here, you see a certain regular pattern, okay, which is bisected occasionally by this other beat, right? And you can, maybe what we have from her looking at the data and telling us what she thought is a super low-cost fetal movement detector. Right? This is not what we set out to look for. So what's on our wish list? Stop, it says. We need access to well-annotated data sets so we can go beyond anecdotal things, as a colleague from biostatistics pointed out. New educational experiences, the same theme. Where do I go to find students who can work in this area? I can't find them in my home department, right? We need cross-trained students. And I think in return, we'll be able to play a much more significant role in managing the costs of healthcare and delivering much better diagnostics.
Any questions for Ramesh? Yeah, David?
What you and your, it sounds very similar to me, like you're both, wishing to advance technology and then handle large data that generates in handling medical problems. Is it two sides?
So what's the difference is your question. I would say the difference is, to some extent, we want to work with widely deployed devices that produce really poor quality data, but lots of it. So this is not medical grade equipment, but it is ubiquitously deployed, right? So there's a different set of challenges in how you extract information from. At the end, you're trying to go after the same issues, but you're setting your boundary conditions.
Yeah, Suresh?
So one of my frustrations of not being equipped to deal with big data is that I feel that a lot of data out there that are being collected under big data are crappy data. And so you end up, wasting a lot of time. So, and for example, you could collect this minute in your life, and we'd have tons of data from metabolomics to other kinds of things. But, it's just one snapshot in your whole life. So are there ways of, using your intelligent networks and so on to really sift through that.
Yes, of course, in the computational community, machine learning methods, you can, without knowing anything about the structure of the data tells you the story of what are the features that are relevant. There is that goes on. But the new dimension that we were trying to follow is, if you let people who might be touching this data also annotate that data, there is additional insights that might emerge. So you add that to it. But I will say something else, going back to my engineering sort of early days as an undergraduate student. When you see data that looks crappy, sometimes there is a story in there. Before you throw that crappy data away, take another look. You might find something useful.
Yeah, you mentioned about the importance of bringing together medicine, machine, and people or patients. Where do you think the most challenge is in bringing these elements together?
Speaking from personal experience, right now, even if you have a lot of data and you manage it very well, if you go in to your clinician and you say, here's a few megabytes of data that I gathered for myself, they have no idea what you're talking about, So there's like this severe disconnect between the data that you can gather about yourself and injecting it back into the medical system, So it feels like you have to train the next generation of students, right? So they will naturally pick this.
Very good. Okay, let's thank Ramesh again.